Hey everybody, welcome to episode 25. I also just learned that it says it on the bottom right corner. So before I've been trying to remember what I typed in, and it actually says it. So I know we're on 25 now. We left off, I was adding some statistics. They should be finally showing up. So if we look at our console log and we look at prints, we should see, I really hope we see mean views adjusted to 4. There we go. We've got 19,000. And then we have, sorry, I was just talking with someone about these values and we were looking at the page view tool and I was trying to justify why my values seem to be way different because I was looking at prints and like his average was at like 9,000 and it didn't occur to me that I'm binning by 48 hours and the page views on the tools are by 24 hours, obviously. So completely explains why I double. Okay. So yeah, anyways, that's the value. And then if we look at I calculated the standard deviation is 8,000, which seems kind of high. But I guess that it's not too surprising because if you look at the daily page views, there's like tons of spikes where, it hit like 40,000 and stuff. So I think that standard deviation seems reasonable. Plus the whole point is I'm just trying to use it to determine when it comes close to being normal again. And 2 standard deviations, which is my current plan away from the mean would be what, 16,000, which means it has to be within like, that would be like under 40,000 page views basically. And you can just tell by looking at, well, this chart here, that seems to be pretty reasonable. Like if it's below 40,000, it's probably relatively close to normal. And you see here, he already actually has a spike that's a little bit of an outlier. So obviously when he's in like the 200 and a million, 200K page range, that's very much going to be classified as an outlier. So the whole point is just to kind of get a sense of what it returns. And I think 2 standard deviations is very safe. Could probably even go with 3 to be honest for like when it's within orbit, but I think I'm going to start with 2. Anyways, we've got that thing. I think the first thing to do is actually just like, I mean, this should be exploration. I think you weren't here last time, Caitlin, but I said I'm already in the code, so I'm not going to do any more in the data exploration files. I'm just going to do it here because I've got everything.
Yeah.
So first, I just want to get a sense of actually like how many days after it actually takes for people to get within normal range. So I think, let's say we have our graphic care. I'm going to close all these. Well, first I want to uncomment these ones again, so I don't have to worry about those loading each time and rendering, because that'll be annoying. Care.js. And the only thing right now we have is the data loaded, and actually I should just hide that video for now. All right. So all we have is the data loaded. Actually, some calculations. So basically for each person, we're gonna like loop over people.data map. And actually I'm just gonna say calculate So let's see. First, I mean, should probably just return the whole object. And then we'll also return, or not days, I guess, because we're in bin, so. Variable that we try to calculate, which is going to happen right here. So This is pretty easy because luckily we've already like filtered our page views, right? We have them as bin death indexes. So we can just look at the ones that are positive. That means they occurred after those 48 hours. So all that prep work we did ahead of time is paying off. So we can say const views equals d dot page views dot filter. We can't use these actually. Let's see. Using d for like my little anonymous functions. X 0. So we're only looking at those. And they're already indexed at 0, which is great because now the count is just literally going to be the one that matches. So we'll filter those first, and then we'll filter again by if actually this is just a one-liner, isn't it? I mean, I could do this all in once, one filter, but separate logic. D dot views adjusted is less than, within, less than the const, what I call it, mean views adjusted before. Mean views adjusted before. And standard deviation. So views adjusted is less than mean plus mean views adjusted before plus standard deviation times 2. I did not like that one. Oh, yeah, it's not camel case. You're correct. And then, assuming there's a match, actually, yeah, because I guess it should filter, so it would be an empty array. I'm not sure what happens if you unshift an empty array. Const equals views dot unshift, or is it shift? I always forget shift and unshift. Unshift. I know it adds one. We don't want that. We just want shift. Pop out the first one. Yep. And then really the count until norm would really be if there's a match, it would be match dot and death index, because that tells us how many things afterwards it was. And otherwise it's null, which means it never happened. And then let's just, and actually I'm not going to return everything for now. For now, I'm actually just going to return a name so we can just have this little table. Whew, let's see if that works. D is not defined. Oh, check it out. Whoa. This is interesting. So according to this math, assuming my math is right, and that's not how you saw, oh, this is sorting by string, huh? Well, that's not helpful. I'm surprised it doesn't let you do a numerical sort. All right, I'll sort it before I table it. All right, so check it out. Actually, just descending. You just unblip.
I did. I unblipped to just go, in agreement.
Okay, cool. So assuming this is true, which I'm not going to assume, that's crazy. 174 days before it settled back down.
Yeah.
I mean, this maybe makes sense.
I mean, yeah, Scott Wheeling kind of makes sense. Natalie Cole makes sense. Wes Craven makes George. Yeah, Tom Petty.
I mean, none of that seems. I mean, that seems like a long time, unless that just means. I mean, first, I'm just going to kind of get and very quickly gut check this. If we can look at. Let's look at all time. So let's see, daily, the median. Oh, so his median was super low. 700. I don't get the sense that this is right. So the median, actually, okay, so this is what we can do. We can look at this, because this is the calculation we're using. So daily averages, we're looking at 600 beforehand. And if we go back to all time, let's slowly zoom here. I don't buy that. I don't think that I did this right. Oh, yeah, because look, he's in the thousands here. So if he was averaging 600 page views a day, I'm assuming. Yeah, so even something like 2,000 is like seems to be way out of the norm. So it said it took how many? Well, 172. That's actually that's really that's basically a year, right? That's 170. That's 340. That's almost a full year. So a full year. So let's see, his death was 620-ish.
Yeah.
So if we look at that, would really just be like now. Is it saying it never really? Somewhere around here, it like must have gone below like 1,000.
Yeah, it stabilized a little.
Whew. That's interesting.
Is there something maybe about his story that?
I think it just like, well, see, look, he's just been getting like in the. I feel there's a few things. So standard deviation, right? So let's actually look. Let's log out the standard deviation as well, because I have a feeling his is super low, because standard deviation, right, is basically like the variance from the mean, kind of. I'm not a statistician, but basically, like, you'll have a really small standard deviation if most of the values are super close to the mean. That's my understanding of how it works. Mm-hmm. So he could have been averaging 600 page views, and it was pretty much exactly always right around that. So like 2 standard deviations could have put him at like 800 page views.
Yeah.
So
might have to adjust.
So maybe we go with like 3. So let's say standard deviation. So maybe we go with like 3. So his standard, it was still 500 page views. And he was getting, 600 on average, which really means, so like his standard deviation was still like 300 page views, or sorry, 2 standard deviations. Wait, actually, that's just standard deviation. So really, we were looking at, so if he was averaging, I'm trying to like rectify this double. If he was averaging like 600 a day, that means 600 more page views. This makes sense. So we should be looking for when it drops below like 1,200 page views in a single day, because that's 2 standard deviations. And you see this here. That perfectly makes sense, right? These are all just like 1,600, 2,000.
Yeah.
So that is pretty significantly different than what he was averaging before, right? If we go back to all time and then just look at.
You can kind of see it in even the all-time graph too, that they're.
See here, look, he like almost never goes above 1,000, right? There's 1, 2, 3, 4, 5, 6. There's like what? This is 2 years of data, and there's maybe 10 times.
Yeah.
So that's how standard deviation works. So like anything above 1,000 is definitely an outlier, I would argue.
Yeah, definitely.
So what we're seeing is that he's pretty much epitomizing the like his he has like a sustained bump after death, and it really doesn't, like, it takes a super long time before he even gets like close to his. Okay, so I think the data is right.
Yeah, it looks, and you like I said, you can see it in the all-time graph as well. It stays bumped.
Yeah, and we could easily, and that's kind of what the next graphic's going to answer, right? Which is like the change from before and after, and his is going to be obviously very significant.
Exactly.
I'm going to just bump it to 3 standard deviations. I don't know what mathematicians how would they feel about this.
I have to go. Bye, Russell.
Bye. So interesting. So some people never come back down, which is actually even more crazy than these ones. But these are still pretty high numbers, even with 3 standard deviations. Regardless, this is actually much more interesting than I was expecting. You even go 4 standard deviations. I don't even know what that means. Okay, so almost everybody comes back in with 4 standard deviations. That looks a lot crazy. I think I'm going to stick with 2 because that's my understanding of a good sense of picking outliers is like 2 standard deviations away. Anyways, I'm leaving that for now, and it's kind of interesting. So we have a little bit of difficulty because like these people are literally going to be off the charts. So how do you plot those? Actually, let me also console log the mean. Actually, let me just round these. That round. I'm sharing this with my team. Wait, oops. I wonder if I can get this full screen. Okay, not quite. Imgur screenshot caption. Use that. Okay, so there's a couple different ways I was thinking about visualizing this. If we go back to the docs, we have the heat map idea, which is kind of like a glorified bar chart. We've got this more distribution-y. I think the main contenders for me are heat map is going to be, it's more going to be like square for each day. Each day is colored views. Or it could be like, standard deviations above. Might get a little more complicated. Or maybe not. This one's like, I call this the heat map bar. Other one is the distribution. I like this one because it's more of a synthesizing, it's abstracting that information. You really just get in like the trend of all the people. We can also maybe use faces or names or something. I might roll out this one. This one's cool, but it's super abstract. This one just looks cool, but I don't think it's basically like the heat map, but you're losing some of the dimensions. You're only using really color. Because time actually doesn't mean anything here, so this is preserving time, which isn't important. So I'm going to scratch that one. Then the other option on chart. I mean, this would work. I guess, again, it could be like how many standard deviations. I don't feel like people understand standard deviations. I don't. This one you'd see the trend, I suppose, more. So I guess that could be like a stepper almost. Right, it's this idea of accumulation, but it's not accumulating. It's no. Yeah, because it's not going to look like this anyways. I'm not feeling that one. All right. So heat map bars versus distribution. So the good thing about this is, let's see, we got like 171 is the most days. I'll be a little tight on mobile. I don't like the doing each. Maybe it's just actually bars, bar on mobile. Doing like a day for each bar, right? 170. You're looking at like 1.5, 2 pixels on mobile, which is going to be tough to read, I think. But it could look pretty cool, actually. You might see it like get darker or lighter and lighter. It could be this cool like fade out thing. This one definitely not going to work how I thought it was going to work. I thought everyone was going to be back to normal a lot sooner. And also, so this one actually is more, I mean, a bar for each person, 90 people. That's going to be a long scroller, but you will actually be able to sort. So it could just, have top ones. And then like a drop down for the rest, because like 90 is, I mean, just, looking at this, and this is like 12 pixels high, 14. No, it's like 20. But like that's super tiny. I'd probably have them. It'd probably be like that big for one person, at least. What is that, like 40 pixels? So it'd be like it's like one giant screen. So it'd be like 3 straight screens of scrolling, which would be a lot. Versus the distribution. Well, originally I was going to do one for each day, but actually I might have to like see if we turn that into weeks. That's 171. Do this 342. 7. It's still 50. That's not like I can't do that. Do by months. 42. No, that's not how it works. That's less than 12 months. For how many? Let's see. Basically, no, because like pretty much no, it's too small. I mean, really, the outliers on this scale are these 3. So I could do kind of a thing where it's, like, see if I did it again by, let's say, week. 48 divided by 7 is it's basically 7. So you could have like do it by week. 1, 2, 3, 4, 5, 6, 7, and then have like a bin for everything above that. I'd be okay binning like the weird ones essentially because it's only 3 people. Um, oops, one sec. All right, I think I'm inclined to do this one. I'm kind of curious about doing names. We had a newsletter if you don't subscribe, but let me find my newsletter. In our newsletter, I found it. Here's two examples of something floating around recently on Reddit. It was pretty cool. So this is essentially an histogram, right? And it's nice because it's like you actually get, you know, abstract the names, which is like so people can kind of check them out. I kind of think this might be a good fit because it's also like everyone wants to read the names, right? That's what you associate with. So I could do this instead of pictures. I don't really know the quality of the pictures we have because they're all from Wikipedia. So we're kind of at the mercy of that. But either way, you would maybe look something like this. If I did by weeks, this is the same deal, but vertical. If I could do it this way, and we definitely would get the longer tail actually. Then we could actually keep it by, let's say, 1, 2, 1, 2, 3. Actually, let me just, what am I doing? Let's do a key. Nest with all right. So binning them by these exact bins, which are 48-hour intervals. We've got 30 things here. The most being null. Second most being 6, 7, 9. It's not sorted. Let's see. This is so unhelpful. Cool. So just looking here, it looks like the bulk is really around this kind of not a smooth distribution. Like 8 is the most, right? At 6, which is about 12 days. And then next is like 14 days, 18 days, and then you see it peter out at around a month. But then random resurgence here. It might be too granular. So I feel like a week might be better. Problem is the dates aren't exact. We have 2. It's really not weeks. I could do it by weeks, so we could just grab that. Actually, I probably should do it by weeks. We could grab the daily. We can do this on the daily pages rather than bins. Let's see. I'll just do like a rough week. Days and per week. Let's do like every 8 days because that's what we actually have actually. But okay, this makes a lot more sense. It is interesting though that there's like a bump. It's two bumps. All right. By the way, there's so many. Actually, that's zero, so let's get rid of the nulls there. Um, it's a crazy number. All right. Um, okay, so let's see. What can I do next? What should I do next? So many choices. How long have I been on the stream? I think I might take a quick break, grab the feedback from the team, and pop back in and start programming one of the charts. Alrighty then. Let's everybody.